Hi guys, so today I just want to take a quick look at what a regular parabola looks like and then what those different letters that we talked about in class have to do with moving that parabola around and making it look different. Okay? So what I've set up over here is a table of values, right, that has my x coordinate here. So I've just picked some x coordinates that we're going to explore, and my y coordinate here, which we're going to get from subbing into the equation y equal x squared. Okay? So first, let's get the y coordinates. Okay? So negative 2 squared is 4. Negative 1 squared is 1. 0 squared is 0. 1 squared is 1. 2 squared is 4. Right? So all I've done is I've taken this x coordinate, subbed it into that equation, and gotten my y coordinate. So negative 2 squared is 4. Negative 1 squared is 1. 0 squared is 0. 1 squared is 1. 2 squared is 4. Okay? So now what I want to do is I want to plot these points. Okay? So first, let's start with the point 0, 0. Okay? So 0, 0 is going to go right at the center. Okay? So that means that we're going to have a point right there that represents 0, 0. Okay? Now let's look at the point next to it, so 1, 1. Okay? So that means from here, 1, 1. Okay? So I'm going to have another point that's right there at 1, 1. Okay? So let's just keep going that way and exploring. 2, 4, I'm going to have a point that's at 2, 4. So that's right there. Okay? And we could even add another one. Okay, so I'm going to add another point that's 3. And if I square that, I get 9. Okay, so I can get another point at 3, 9. Okay? So there's my third point. Okay? So that means that on that side, my graph is going to look like that. Okay? Now, going to the negatives, okay, so these numbers represent our negatives. Okay? So for negative 1, 1, I'm going to be here, I'm going to go negative 1, 1. Okay? So that means I'm going to have a point at negative 1, 1. Okay? For negative 2, 4, I'm going to have a point at negative 2, 4. Okay? So that means right there. Okay? And I'll even include another point that is negative 3, 9. Okay? So that means I'm going to have another point at negative 3, 9. Okay? So what that means is that on the other side, my graph looks like that. Okay? So now, the important thing to notice is that the graph is perfectly symmetric, going one way and the other way. Okay? So do you see how now we have our axis of symmetry formed? Right? There's our vertex. There's our axis of symmetry. There's our optimal value. Okay? So let's note down some important things about this parabola. Okay? So there is a vertex at 0, 0. Okay? There is an axis of symmetry that goes right down the middle. Okay? And the graph is perfectly symmetric around that axis of symmetry. Okay? Now, I do want you to notice another thing. Okay? And what I'd like you to look for is this pattern that we have walking away from the vertex. Okay? So as I go 1 away from the vertex, I go up 1. Okay? If I go 2 away from the vertex, I go up 4. So 1 squared is 1, 2 squared is 4. If I go 3 away from the vertex, I go up 9, which is 3 squared. Okay? So again, we're seeing 1 and 1 squared, 2, 2 squared, 3, 3 squared. Okay? And same thing on the other side. 1, 1 squared, 2, 2 squared, 3, 3 squared. Okay, so we're going to talk more about that. But now I want you to remember what I want you to think about is what all these different letters did to our vertex. Okay? So I want you to remember that this k value that we called it, right? So if I had x squared plus something, okay, that made my graph shift up. Okay? So that made the vertex move up. Okay? If I had an h value, so if I had something inside the bracket, inside the square bracket, okay, that made my vertex move left or right. Okay, so that's going to be important to us. And finally, if I had an a value multiplying the x squared, okay, that made our parabola, I know a lot of us said that it horizontally stretched, but actually what we're going to try to look at is the vertical effect on this parabola. Okay, so this parabola will be vertically stretched by a factor of 2, or vertically stretched by a factor of 3 for the red one. The blue one is actually vertically compressed by a factor of 1/2. Okay? So that's what we're going to work on in class. Thank you very much for watching the video, and I'll see you guys in class.